Okay, now the third part of the video be this. Here, I want to try explain how Einstein resolve that dilemma. You know, after he done try think within the constant speed of light fit mean, you know. Incoming, you know, take him long before he begin focus on the composition of speed. That is waiting speed they made up of, which is distance and time. You see, so in peak time first of all, in come begin to think, what's in this thing fee mean really? What exactly is time? Now the first way begin come in mind with that. So in come begin to think, in what in we today scientists they call them thought experiment. In come imagine say, look, if person they inside car, like sometimes maybe you dey garage, they wait for bus make it full, so that we now begin travel go either east or north anywhere. So you sit down for outside as passengers they comes person dey inside car. Imagine say person dey inside car and in carry one device like that, one type of clock, what they call light clock. You just imagine a hypothetical kind of clock like that, and inside I've seen there with the light clock basically now something like this. Anyway, you just imagine, I'm sure you get two mirrors, one mirror here, the other mirror here. Then you can't get one, you know, light. Let's imagine say one single particle of light like this. It bounce between these two mirrors. You understand? If they try to understand what in time be. So when we say time, what exactly do we mean? What exactly we mean by time? You can realize, say, oh, when we say time is actually period. The period where something take place. Maybe an event like wedding. Let's say if wedding starts for 1 o'clock, the very point where the thing start 9 minutes, and it can't end, let's say 3 o'clock. It means the period where the wedding take place, where the event take place, 9 be time. So when we talk about time, it's actually a question of the period where something happen. You understand? The period where, for example, the event where they concern a wedding. The period where, all through the period where the MC say, okay, wedding not start to, where they do all the blah, 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 say, okay, wedding don't finish. When he say wedding don't start with the clock, that time we say wedding don't start, the clock hit 1, bam, on the dot like this. Then see, the time we say wedding don't finish, that time when they say wedding don't finish, if it coincide with 3 o'clock, then we say the period of time between these places, the period where event take place. So which time the event wedding take place? It will be 3 minus 1, which is 2 hours. So if the time where the MC say wedding not start to clock hit 1 o'clock then, and the time we say wedding not finish, clock hit 3 o'clock then if we say the period where the time where the event take, now as clock move from here go here, which is 2 hours interval. So if you say the event take place for 2 hours, now what do you mean by time it is simultaneous at the same so simultaneous now it's sorry, I don't focus. Anyway, so time, if we want to talk the period the time where the thing take last, if it start for 1 hour, 1 o'clock and end for 3 o'clock, it will be 2 hours. So this idea 9 inconsistency, oh, time now actually the period where something take last. So you can say, okay, look, imagine a person carry one thing for hand. You get 2 glass, like one box, you get 2 glass like this, and the you get 2 mirror here, and then this side all the wall na glass. So you get one particle of light like this, maybe one green dot. We just they bounce from here between these two things, they go up and down. So in come imagine say, okay, since time na period where something take place, how will we take envision, how will we take imagine time they take place for inside this thing now? Now you can say, okay, since it be period, more just take the time to be the period where that green dot, green light where they shine, move from here, go up here, come down to the same place. So the period where you make this journey, this to and fro journey, one to and fro journey, more column time, which is t. Of course, this distance here, more column d. You understand? So this person, I seen they inside car. Let's say the car come begin to move. As the car begin to move, it just be like you. When you're inside car, where you throw your key, go up. You go come down for the same place. Let's say the window of the car they blinded. They put curtain there. You know, get anywhere where you feel. Imagine say the car they move, and you carry this device for your hand like this. So this green particle of light, just they gyrate, they move anyhow between these two places, between this mirror, they bounce between these two mirrors like this. You as you carry them, now for the same place the thing go they happen. It just be like you dey inside your car they move, maybe driver the driver now, you can't throw your key, they go up, come down like this. You go always, they go come back. For you, where they see them, you be like say, now for the same place the thing they happen. You understand? So since you carry this this device like this way, this green particle that they bounce in between, it will always they happen for the same spot. So for you, if you want to calculate the speed at which this thing they move now, it will be, you know, since we say speed, in this case, since the particle of light they talk about, now c will call is equal to distance all over time. Since we say make the distance between these two places be d. So how much distance the thing cover? From here, go here, and then come back. So it cover 2d all over. Let's say the time we carry do the return trip, na t. We just call them t1. Okay, ta. Let's call this instance a. I want to try to explain to you now how intake resolve that issue mathematically. So now, you can imagine again. This one is the first scenario we imagine. You can imagine again, say, as this guy, as you dey inside car, they move. Imagine see another person there outside here. They look you as you hold the thing for hand. They observe the same thing too. He carry your own time too, your own clock. You carry your own clock. The time we measure this thing, move up and down. The time we measure move up and down at t, go one round trip. And this one, now your own situation be this. You were the inside car. Let's say na situation A. Now we'll call them. Then this person they look the same thing as the car they move. You understand? So this person they observe the same. You here now you here. You see carry the thing inside car here. So you they move. In they observe the thing, I say they carry your own time too. You want to see the time where this thing take move up and down. The same round trip where you do. And your car they move, go this direction. They move go front from them. They move go front. So in the watch waiting they happen. You understand? Now, if in the watch waiting they happen, waiting in go see. In go see say, while you inside your car, you see, you carry the thing for hand, they drop for the same place, you know, so this thing they happen for inside car. If they inside car where they move, where they throw your key, go up and down, it go always they come down for the same place. But person with the outside, what you go see? Let's say, you see the dot there here. So as you begin move, in come on your own clock. So as the thing they make one round trip, what thing go they see be say, while you for inside your car, you go to see the thing they drop for the same spot. You go to see the thing they move because the car they move here too. You go start from here, they go this way. So by the time where the thing go hit up here, while you're there inside your car, now the same place the thing they happen, you go to see them they move this way because the car they move away. So you go start from here, go move like this, come this mirror here. Before you go reach this mirror here, your car go down reach this point. You still there inside the car. Since the car don't come this point, then as the thing they make return trip, they come down. While you see the thing they come down for the same spot. You go say the thing they move this way. Since your car still continue they move till it will come this spot. You understand? Now what thing go they see be this? You understand? You since you're inside the car, it be like everything they happen for the same place. If you throw your key go up, it go always land for your hand like the same spot. Let's imagine say you know fit no say your car they move, maybe the window cut in there, you know if you hear the engine of the car they run. So if you throw your key to go up like this, now always for the same place, now anything go happen. So as the thing leave the mirror where they ground, you on your own clock. So the thing travel go up, it hits the first mirror for up. Then they come down. As you reach down, you stop your clock. You measure the time where you can't make the trip. So for you, now what you go to see be this. Then imagine say as they do that one, another person there outside, they look you. Your car they move. In the see the thing they move. So what you go see as the thing leave this pot for your hand, they go up where they see and they go up like this. You go to see them they go this way. You go to see them they go this way because your car they move too. The forum. This green particle not gonna make straight line again. They go slanty way like this. Since your car, and by the time where the thing go hit the first mirror forum, where in the sea, your car go down move come this point. Then as they come down, your car go down move come this way before it go hit this point. You understand? So let's say your car they move with this speed, u meters per second. We'll just use u to denote them. And this one is situation B. Remember situation A. Now when the car, the difference between this situation and this situation, we say here your car they on one spot. Here your car they move. So in this situation where you dey one spot, him too sit down, they move. What you they see, now you go they see too. But as your car begin move, what you go see no go change. Like you don't see before for inside your car. Car, if you sit down inside car where they move, where they throw your key go up, it go always they come down for the same place. But person where they outside where they see waiting happen, see the thing they go straight line up and down, vertical line like this. You go to see them move in a slanting way. Why? Because your car they move. So as you throw your key go up, let's say your car there at this point. As you throw your key go up, your car they move like this. So the thing go they move come here. Till you go reach the maximum height or the second mirror. Here. Then as they come down, your car still they move, you go come here like this. So now we think this guy go they see they happen. So while you measure the speed where the thing take happen as distance all over time, which is the distance where the thing take cover, it move from here, go here, cover one distance, 1d, and then still come down the same distance again, 2d. So the distance where the thing cover now, 2d all over time, the time where you measure, which is TA. You understand? So denote different times. Now, for the second guy here, this one is situation A. In A. In situation B, where the thing don't move. Now, still the same thing you go see, but what thing this guy go see? Now, he go measure. Now, remember, Maxwell said the speed of light is the same thing for everybody where they see the thing, where they measure. Like I explained to you the other time, if you with your friend now they do 100 meters race, as now they go, your friend they move past you, they first you they go because in the inside they run past you. If your referee come on touch, that the rays of that, the flash where the touch will take flash, the lights go pass on. Una not go measure my different speed, that's still the same speed where you take see the thing pass you. Now in that person to go see the thing pass them too. You understand? So inside the speed of light will be the same. So the speed of light is still the same thing. C. For the 12 now to take measure the speed of light to be the same. What thing they happen? So now the distance where this thing travel here. Now remember, it not be it can't long pass the distance where this person see this thing travel here. It can't long pass the distance where you wait there inside the car see the thing move. As if you see from the diagram here, this one long past this one. So we'll not call them D again, we'll call them L. Just to differentiate the two distances. And since the thing they move are the same, since here now the distance here now L, here will still be L. So in place of D here, as this guy, this one, 9 be waiting this guy they measure, it will be 2L all over. The time when you take measure and more column TB, because now situation B, 9B own perspective. So we call them TB. You understand? Let's call this one equation 1 and then this one equation 2. You understand? So now we'll try to solve this thing. Now if you look here now, can be like one triangle. Then here we get right angle triangle here. Now for those of you who not to understand math like that, where they fear math is okay. Not be everybody get, although I not to believe that thing, but it's okay. I don't believe say some people they will know if you understand math. Maybe now the way person teach you, now you know if you understand them, something like that. But it's okay. If you know if math they hard it to understand, it's okay, just wait. Maybe at the end of this video you go see, I go write the equation to you and I go explain to you how Einstein takes say time day different for everybody. Now right angle triangle be this. So we go try see how, for right angle triangle, according to Pythagoras, Pythagoras theorem, he say the length of the hypotenuse, the square of the length of the hypotenuse is the same thing as the square of the opposite plus the square of the adjacent side. So to find this L, we know say L squared from Pythagoras theorem is equal to, now here now still D, because now D, 9B all everywhere. Now from here to here, we call them delta X. That is the distance, the physical distance where your car take move from this point where the thing begin making journey to the point where the thing come back, finishing journey, come back. We call them delta X. So since the whole of this place is now delta X, and this line cuts this thing into 2 equal halves. So here now go be delta X all over 2 and then delta X all over 2. You understand? So the length of the adjacent side now will be delta S all over 2. So now, using Pythagoras theorem, the square of this side is equal to the square of this side and also the square of plus the square of this side. So it will be D squared plus delta X all over 2 squared. We know this is the formula for Pythagoras theorem. Pythagoras theorem. Now, to make L subject to the formula, we need to take this one away, go this side. So this one becomes L is equal to the square root of D squared plus delta X all over 2 squared. You understand? So now this is the formula for L. Now 2L. Now we'll go try, so let's call this one equation 3. So what we'll do now is say this value of L, we'll try to take them, make we put them inside here. So now from B, we'll say putting 3 into, we have that C is equal to, which is the speed of light here, 2L all over TB, which is still the same thing as 2. What is L? L here. Now, the square root of D squared plus delta X all over 2 squared. Then all over TB. This same TB will bring and come here. So we'll try solve, we'll try find waiting, all these things what they do now, waiting Einstein doing in those days. So as they follow this thing, say now, inside the mind of the same Einstein, how they go. Okay, now, we will carry this whole thing here. If you look, we first find D. Okay, first of all, more do subject to the formula. If you do cross multiplication, the whole of this one is still equal to is equal to C all over 1. So when you do cross multiplication, this one go times this one go times this one. So C times TB will give you CTB is equal to the whole of this times 1. Anything times 1 is still that same thing. So we still have a 2, the square root of D squared plus delta X all over 2 squared. You understand? Now, from here, from this equation 1, we know so we still find D bar. So that we express this D in terms of C and TA. You understand? Because we they focus on to find the relationship to one try verify if what Einstein talk not true. That this time where this person go measure and this time the time where you go measure for the same event to take place, no go be the same thing. So now what we will try find here. So now from equation 1, if we can say from equation 1, we know that C is equal to 2D all over TA. That implies that if you do cross multiplication, this one times this one will give you CTA is equal to 2D. Now divide both sides by 2 to make D subject of the formula. So now we have our D is equal to CTA all over 2. So let's call this one equation, let's call this one 4. So now what we will do now is say, sorry, we'll call this one equation 4. And then this one equation 5. So what we will do now is we'll take this 5, put them inside 2, put them inside 4. So now here becomes CTB is equal to, we'll say, putting 5 in 4, we have CTB is equal to 2 the square root of, now CD here will come out and put this one inside. So it will become CTA all over 2 raised to the power of 2 plus delta X all over 2 squared. You understand? So now what we will get be this. So now what will be the next thing we'll go do? We still get this problem here, delta X. So we'll try and see how we'll find delta X from all these places. Now remember, as this guy with the outside, they look you. For him, this your car where they inside they move. At what speed? U meters per second. And he cover this move from here to this point. So the distance where he cover be this delta X. You understand? So for him, if you say okay, but in situation B, this guy, he saw him look here. See, say your car move. He move at this speed and he cover this distance. You see, so what in the speed? Speed which is U meters per second is equal to distance all over time, which is delta X all over which time? The time we take move this distance, I see your TB. So all over TB. So if we do a cross multiplication, we are going to have that delta X times 1 will give us delta X. Since anything times 1 is still that same thing, is equal to U meters per second times TB will give us UTB. You see? So now let's call this one equation what? Let's call this one equation 6. So now we are going to put, here now equation 6. So let's call this one 7. You understand? So now we're going to put this one in place of delta X in this equation 6. So we are going to say putting 7 in 6, we have CTB is equal to 2 the square root of, now the whole of this CTA all over 2 squared plus, now remove this one, put this one inside, UTB all over 2 squared. So this is what we have. You see, sorry, and you know, I don't forget this. Okay, you did correct, you did correct. So what we'll go do now, we'll try empty the sides more. So we'll divide both sides by these 2. But before we do that one, I would like to see if we fit turn this camera to this side. Now let me do this thing. So now, since now we will get with this, we'll try divide both sides by. We will try divide both sides by by 2. So here we have CTB all over 2 is equal to the square root of, we have what? CTA all over 2 squared plus UTB all over 2 squared. Now divided by 2 too. So the whole of this one. So now we go divide this one here. So now we'll come get CTB all over 2 is equal to, now just this one only, CTA all over 2 squared plus UTB all over 2 squared. Now, what we'll go do here now is see, we go try expand this whole thing. So when you expand this whole thing, what it go give us first of all? Now, you know this square here belongs to everything inside. So we have the square root of C squared T A squared all over 2 squared is what? 4 plus, we try to remove this bracket. So to remove this bracket, we'll carry these 2 belong to everything here. So we'll put 2 on top everything. So the same thing I will do here too. So these 2 belongs to everything here becomes U squared TB squared all over 2 squared is what? 4. So now still the same thing way you go find. And of course, to bring the whole of this one down, CTB all over 2. Now, we go first leave this square root sign. I'm going to solve this one with the inside first of all. So now we'll come here, bring this one come out. First of all, we'll say C squared T A squared all over 4 plus U squared T B squared all over 4. So now we'll try and look for the LCM of this one. LCM here now waiting. The LCM of 4 is what? It's still 4. So 4 into 4. Anything into itself is 1. So 1 times the whole of this one. Anything multiplied by 1 is still the same thing. So we have C squared T A squared plus 4 into 4 is still 1. 1 times the whole of this is still the same thing. So we have U squared T B squared. So now we'll carry this whole thing here, bring our mentor inside under this canopy again, this square root sign, canopy. Let me finish this. Okay, so now we don't solve this one, so we'll go carry this one, bring and come here now, and then return this canopy on top of them. So it will be C TB all over 2 is equal to, you bring back the canopy, then carry this one, put inside. So it will be C squared TA squared all over, sorry, plus U squared TB squared all over 4. You see? So now what we're going to do is we'll carry this square root sign now, go this place. So this one will come big on top. So it will be C squared, because by the time you carry this square root sign go here, you come turn to square. And it will square everything with it inside here. C squared TB squared all over. Now, 2 squared is what? 4, right? So is equal to, now this one will come get canopy on top again. You can't do open like that. So we get C squared TA squared plus U squared TB squared all over 4. So for mass, if you get something like this, what we're going to do is say we'll multiply both sides by the denominator, since the denominator are the same thing. So we'll cancel them out. So if you multiply here by 4, multiply here by 4. So this times 4 times 4. Divide this one here, divide this one here. So the 4 now don't cancel themselves out. You can remain this one with it on top. You understand? So I'll just simply say 4 into 4, leaving behind this one. So we now have, so we can get C squared TB squared is equal to C squared TA squared plus U squared TB squared. Now for mass, if you get something like this, by if you see here get TB squared, here self get TB squared. So what we're going to do is we'll collect like terms. This one is something we don't learn for primary school before. We'll carry this one come here like this, and since this one here is a plus, well, it can't come here, come turn minus. So we get C squared TB squared minus U squared TB squared is equal to C squared TA squared. You see? So now here, if you see here now, this one gets TB squared, TB squared. So we'll collect, we'll come out this one. Then we'll get TB squared bracket C squared minus U squared close bracket is equal to, then this one here, C squared TA squared. You understand? So now what we'll get now be this. So now if we get something like this, to make this TB stand alone, what we'll go do? We'll need to divide both sides by bracket C squared minus U squared. So now what we'll go do here with that? Here we get TB squared bracket C squared minus U squared is equal to this one, C squared TA squared. So now what we're going to do is we'll divide both sides by bracket C squared minus U squared. So here now becomes C squared minus U squared divided by C squared minus U squared. So now this one will enter this one. So these are TB squared constant alone. Here we get TB squared, no be tuberculosis, so TB squared is equal to C squared TA squared all over bracket C squared minus U squared. Now, if you look something like this, we'll still need to try empty this place further. You get any way if you commode the speed of light, which is C squared, the square of the speed of light. We don't need them. So we'll try find one way we'll make this place simpler. Here get C squared, here get C squared. So find one clever way if we cancel those ones out. How will we do one? Now if you look here now, you get any other way if you write this thing we will make them possible. First of all, if we carry the c squared comot, c squared bracket, if you divide everywhere by c squared, here will come be 1 minus u squared, right? So that by the time we will expand this bracket, we'll get this one. If you multiply c squared, u squared all over c squared. So that by the time we multiply this whole thing here by c squared, you'll still get this one. More try and see. C squared times 1 will give you c squared, right? C squared times u squared divided by c squared. You get something like this: c squared times u squared divided by c squared. Now this one will cancel this one out, so we can't get only u squared. So now what do we get for here be that? You understand, huh? This is simple. Now we'll come out this one, come put this one inside. So we get our tb squared is equal to c squared ta squared all over c squared bracket 1 minus u squared all over c squared. You see? So now we don't come out this one, come here. Now if we cancel and come out, since we don't need that, cancel this one, cancel this one. So now we know that our tb squared will become ta squared all over 1 minus u squared all over c squared. You see? Now what we can get now be this. Now if you look here in our tb squared, we'll try to look for where we will reduce some more to in lowest term. If you carry the square, go this side, you'll become tb is equal to the square root of ta squared all over the square root of 1 minus u squared all over c squared. Remember, if you carry this square from here, go this side, it will become square root of everything. Square root of this one, square root of this one. Now, this square will cancel out the square root. So we'll come to say our tb is equal to ta all over the square root of 1 minus u squared all over c squared. You see? So now this equation here in Einstein they call time dilation. So if we first even do them this way, by the time we cross multiply, this whole thing will become tb square root of 1 minus u squared all over c squared is equal to ta. Where this ta, now your own time, you will sit down inside the car, we hold the thing. Now the time we measure that event, the event where that green particle of light move from the mirror where they down to the mirror where they up and come down again. So that event of this thing moving this way, the time you measure that to take place, and the time the other person where they outside, where they watch it and it happen, measure the same thing. So the time where you measure that event take place, 9 be ta. The other person where they outside, the time where you measure the whole thing, 9 be tb. So if you see, your time and in time for be the same thing, if not for this factor we can come inside. So remember this u here, now it represents the speed where your car they move. You see, no worry. In our next video, I will show you how we go think about this whole thing, how to properly think about it, so that by the time, so that you will get intuitive understanding of these things. So if you still want to hear the next, although this video contains so much math, it is very boring, I know, you see, but just try watch the next one, make you understand where I go try explain what these two things mean. Thank you. I don't do this thing for ordinary English. If you check the other, if you know really follow this one I do for Pidgin English. If you check the other English one, make you try understand better. I think that one they better than this one what I do today. I know they inform. Thank you.